Okay, we're going to talk about trigonometric functions. So we're going to talk about the basic triangle, and here are the basic trig functions that we learned last year. We reviewed these in class. So sine is opposite hypotenuse, adjacent, cos is adjacent hypotenuse, tan is opposite adjacent. What we're going to do is we're going to take our basic right triangle over here, and we're going to move it and place it onto the XY grid. So this is still, this here is the opposite, this here is the, sorry, I got that wrong. This is here, this here is the adjacent, this here is the opposite, and this here is the hypotenuse. But we can also use x and y to represent these because this is the x-axis and this is the y-axis. So this would be how far along the x-axis you went, or x. This would be how far up and down, or y. Now this is, if I used Pythagorean theorem, I could say it's x squared plus y squared equals, now they call it r squared because it has to do with the circle, which we're not going to learn about right now, but they do that just so you know where that comes from. So we'll just call this r for now. Now instead of using these basic values, opposite and hypotenuse, we're going to substitute in the letters over here. Okay, so sine would be y over r because it's the opposite over hypotenuse. Now, I want you to try cos and tan yourself and then check that you got them right. So cos is x over r, and tan is opposite, which is y, and adjacent, which is x. And there would be the values. So if you were trying to represent them, I'm just going to delete that E. If you're trying to represent them, you could use them using these formulas. So it's the y value over, so it's the y value over the r value, x, r, y, x. You'll see how this all relates together in the next slide when we look at it. Okay, so here is a basic chart of all of the different quadrants. So here, this is quadrant number 1. This is quadrant number 2, this is number 3, and this is number 4. So what I've done is I've just drawn the triangle in each of the 4 quadrants so that then we can look at what the sine and cos and tan is. Okay, so again, this is x and this is y and this is r. This is, now instead of going positive, this is negative x here. And this is positive y, and this is r here. You'll see why the negatives and the positives become important in a minute. And here, this is, again, negative x, but it's also negative y, and this is still r. And the final one, this is positive x and negative y and r. So now if we write the sine, cos, and tan for each of these, I want you to try this on your own, and then I will write them all down for you. And I'm going to pause the video now to let you guys do that. Okay, you'll notice that I've done the first quadrant, which simply is a copying of the first page that we wrote it down. The second one is a slightly different because you'll notice that there's some negatives. They're the same, but cos and tan are negative. That means that sine is positive here. Okay, so the sine value in this quadrant is positive. All of them, you'll notice over here, are positive. So all of them are positive here. Just the sine is positive in that second quadrant. So now I'm going to get you to pause it again, and I'm going to pause mine, and I'm going to write in the values for the third and the fourth quadrant. Okay, so I'm just going to pause this for a second. Okay, now I've written down all of the values for each of these, and you can pause the video and write them down. I am never going to be expecting you to remember all of these. This is not a memory thing. It's just to show you what it is. So here you'll see that sine is opposite over hypotenuse, so it's negative y over r, and so on. That's how I've got them all. Now, the thing that I really want you to notice, what I want you to notice here is which ones are negative and which ones are positive. Now, if I look down here, if I have two negatives, that makes this a positive. That means in this quadrant, tan is plus, and the other two are negative. In this quadrant, in the fourth quadrant, the only one that is positive is cos. So cos is positive. I have a little way of remembering this that I learned in school that might help you remember how each of them. So I'm just going to open a new page and I'm going to show you how I remembered them. Okay, and you can take it or leave it, but this is the way that I learned. Now, when I was looking at the previous slide, all of them were positive in the first quadrant. In the first quadrant, sine, cos, and tan were positive. In the second quadrant, only sine was positive. In the third quadrant, the tan was positive. And in the fourth quadrant, the cos was positive. Now you can go back and check this for yourself if you want. But the way that I remember it, it's called the cast rule. So cos is positive here, all are positive here, sine here, and tan there. It's just a good way to remember which ones, where they're positive and where they're negative. Because that'll come up when we're actually trying to calculate the values of an angle, and you'll see that in a minute. Okay, so we talked about the reference angle in class on Friday, and I just want to write it down for each of the four quadrants so that you have it. So the reference angle here is simply the same as the angle. For this quadrant here, it's 180 minus the angle. And for this one, it's 180 plus the angle. And for the last one, it's 360 minus the angle. So we covered this in class, but I just want you to have a look at it again, and then you can have it written down somewhere else as well for each of the quadrants. Okay, so maybe you'll have a nice big picture of each of the quadrants for yourself with lots of detail on it. So now I want to apply this to some different examples. So the first example is a point P lies on the terminal arm of an angle in standard position. Determine the exact trig ratios for sine, cos, and tan. So the first thing we're going to do is we're going to take this point and we're going to graph it on our line, on our xy. So it doesn't have to be exact. I just want you to get a rough idea and just a sketch so you know what it looks like. So here it is, and we go minus 8, which is this way. So minus 8. And then it says 15y, so that's going to be that way. And here is our triangle, and here is our angle. Okay, so this is 15. Now to find out what this r is, again, we use the Pythagorean theorem. So we say 15 squared plus negative 8 squared equals r squared. So this is 225 plus 64 equals r squared. And that gives me an r equal to 17. I added those up and I took the square root. I got 17. That makes this equal to 17. Now I can write all of the trig ratios for this. I'm just going to move this down a little bit so that we give ourselves a tiny bit more space. And so we've got sine of that angle, we got cos, and we have tan. And all we have to do is take the values that are on there. So the sine is opposite, so it's 15, and the hypotenuse is 17. Now, is it positive 15 and positive 17? Yes. So this is positive. Now, cos, it's going to be adjacent, which is negative 8 over 15. And the tan is opposite over adjacent, so it's 15 over negative 8. And that's it. That's all you have to write for the exact values. So if you could try the second one on your own and then check your answers with what I've done. Okay, so the point P, negative 4, 7, lies on the terminal arm of an angle in standard position. Okay, so 4 is this way, and negative 7 is down here. So that would be this. So this would be 4, and this would be negative 7. Negative 7, sorry. Negative 7. So now you find r. So you go r squared equals 4 squared plus 7, negative 7 squared. Again, you can write it in the opposite order, whatever makes the most sense to you. R squared equals 16 plus 49, which then r is equal to the square root of 65. And we're just going to leave it like that. Okay, we're going to leave it as the square root of 65 because we want to have the exact values for sine, cos, and tan. Okay, I'm giving myself a little bit more space again. And then I'm going to write sine of the angle. So the angle's in here. And cos of the angle. And tan of the angle. And that's equal to sine is opposite, which is negative 7, over hypotenuse, which is root 65. Cos is adjacent, which is 4 over root 65. And tan is opposite over adjacent, so that's negative 7 over 4. And you're done that. That's a negative 7. So I'll just erase that so that it looks a little bit more like a negative 7. Okay, so we're going to consider the question just written differently, but the exact same type of question. So suppose that theta is an angle in standard position with the terminal arm in quadrant 3. Okay, so that means we have to look at quadrant 3, which is 1, 2, and this is 3. So it's going to be down here in this quadrant over here, okay? And it says that cos is this. So cos is adjacent over hypotenuse. So let's draw it. So if it's quadrant 3, it's got to go this way, negative 3, and then the hypotenuse is 4. So this is a negative 3. And the hypotenuse is going to be 4, but we don't know this value here. So we have to find that. We have to find the y value. Okay, so we'll just write that in as y instead of that just a letter. So that's y. So we need to find it. So again, we use our Pythagorean theorem. So r squared equals x squared plus y squared. We're trying to find y now, so we have to rearrange the formula at the end. So this is 4 squared equals negative 3 squared plus y squared. And this is going to be 16 minus 9 equals y squared. 16 minus 9 is 7, and so that gives me y squared, and y is equal to square root of 7. Okay, so it's also negative because it's down, so this will be negative square root of 7. And we're just going to leave it that way, and then we're going to write our sine, cos, and tan. We know our angle is here in that corner. Okay, so we have to write sine, and we have to write tan. We know cos because they gave it to us in the question. And we're going to write our symbol in there for theta. Okay, so sine is opposite, so opposite, which is negative root 7, over hypotenuse, which is 4. The tan is adjacent, which is negative 3, over the opposite. Sorry, it's opposite over adjacent, right? Opposite over adjacent. So let's get this right. So it's opposite, which is the negative root 7, and the adjacent, which is negative 3, and that makes it positive because it's two negatives. Okay, so root 7 over 3. We're going to leave it there for now, and on Monday's class we're going to talk about how to apply this more